Today we are going to start looking at parallel and perpendicular lines and their slopes. Parallel lines have slopes which are equal, but the y-intercepts are different. So let's just look at a couple examples. If we have a slope of 2, a slope parallel would equal 2. If we had a slope of a half, parallel slope would be a half. If we had a slope of -3, a parallel slope would be -3. Perpendicular uses a little bit, two different things that have to happen. The slopes are opposite reciprocals. Opposite meaning one is positive, one needs to be negative. And reciprocal, that's where you have the flip going on. So meaning you have your fraction and it's flip-flopped. So for instance, if we had the slope of 2, perpendicular slope would need to be negative because this one's positive. So 2 is really at 2 over 1. So this is going to be -1/2. A slope of 1/2 is going to be negative, first of all, because that's opposite. And then when we flip it, it's going to be 2 over 1, so -2. If we had the slope of m equals -3 over 2, a perpendicular slope would have to be positive, and the reciprocal of it would be 2 over 3. So let's look at example 1. We need to determine if these two lines are going to be parallel, if they're going to be parallel. So first we need to take a look at this line that contains these 2 points, and we need to find our slope. So if we do that, we need to take 1 minus 2 over 3 minus a -4. 1 minus 2 is a -1. 3 minus a -4 is a +7. So our line M has a slope of -1. And then our second line, we need to find the slope. So -2 minus 0 over 8 minus -4. -2 minus 0 is a -2 over 8 minus 4, which is 12. If we reduce this, 2 goes into both, so 2 goes into 2 one time. 2 goes into 12 6 times. So these are our two slopes. These are not parallel because they are not, because these slopes are not equal. We need to determine if these two lines are parallel. First line, here's our slope, it's a half. Second one, we have to put into slope-intercept form to get it to be, so we can find our slope. So first we subtract 2x to both sides. 2x minus 2x is 0. Fill it with -4y equals -2x plus 12. Last step, divide -4 to both sides. Everything, sorry. -4 divided by -4 is positive, so we're left with y equals -2 divided by -4 is a +½ x. 12 divided by -4 is a -3. So this equation, the slope is a half. So since they're both the same, yes, they are parallel. And they are parallel because the slopes are equal and the y-intercepts are different. Last example problem for parallel lines. We need to write a new equation that's parallel to this line and goes through our point 4, 1. So to do that, we need a slope of -2, and we're going to use point slope form. So our y is 1, so we want y minus 1. Our slope stays the same, so it's still -2. X is -4, so we want to say x minus 4. So there's our new equation that's parallel to this line and goes through that point. Let's look at some example problems with perpendicular lines. So let's do the same thing we did with parallel. We need to find the slope of both of these. So we have -6 minus 8 over -4 minus 0. Negative 6 minus 8 is a negative 14. Negative 4 minus 0 is negative 4. If we reduce this, we end up with a positive 7 over 2. In our second one, we can do 7 minus 9 over 5 minus negative 2. 7 minus 9 is a negative 2. 5 minus a negative 2 is a positive 7. Looking at both of our slopes, they're opposites. One's negative, one's positive, and they're reciprocals of each other. So yes, they are perpendicular. And they're perpendicular because they are opposite reciprocals. Let's skip over example 5 and just go straight to example 6. We need to write a new equation that is perpendicular to this line and through this point. Right now our slope is negative 3, so a perpendicular slope means it has to be positive, and the reciprocal would make it 1/3. So we want an equation with a slope of 1/3 through this point. Y is negative 5, so we want to add 5. X is positive 6, so we want to subtract 6. So this is our new equation, perpendicular to this line through that point.